Okay, now we will put everything together that we have learned and we're going to sketch some graphs, graphs of sinusoidal functions. And this is actually not too hard. The main thing you have to do is find all the things that we learn about amplitude and period and all that, and then keep in your mind the basic shape of whatever type of graph you're going to draw. So if I'm trying to draw a sine graph, then I need to have this in you either keep it in your mind, in your head, or just draw it in a corner and use it as reference. It will take you all of, maybe 30 seconds to draw a sketch of this with some accuracy because you're going to be modifying these points in, in your new graph. All right, and same with the cosine. All right, so let's start by finding all the things that are going to be needed. First of all, the amplitude. You remember what that is? That is the absolute value of A, and that is going to give us the height of the wave, right? From the midline, the highest point that the wave reaches, that distance. Okay, so what is that? This is the absolute value of 2, which is 2. All right, then the next thing, period. Period is a formula 2 pi over b. All right, and this is 2 pi. The b is pi over 2. And then simplifying, this is, what is that? You simplify that, you get 2 pi times 2 over pi divided by something the same as multiplying by the reciprocal. So now you can cancel the pi's and you get 4. So the period is 4. That means the graph, the main piece of the graph is going to repeat itself after every 4 units. Then we have the midline, y equals 1. That's the midline. Right, and the vertical shift is 1 unit up, 1 unit upward. So the basic graph is shifted up 1 unit upward. That is the t. Remember, I'm using the t for both of these things. And lastly, I need the phase shift. How much the original graph has moved to the left or to the right. So what is the phase shift? The phase shift, the formula for that is c over b. Now the c here in this problem is 0. There's no c. So this is going to be 0 over pi over 2, which is 0. That means there is no shift, no phase shift. So the graph does not really move horizontally, left or right. Okay, once you have all these things, now you're pretty much ready to start drawing your picture. Okay, and remember again once more that we really need to have this either in a corner or in your head if we're going to be making reference to that. All right, so now I'm going to draw my axis. Okay, those are my axes. All right, so this is a sine graph. So the sine starts at 0, but also note that, as I said, I think before, there are there are 5 main points, 1, 2, 3, 4, 5, but 4 sections, 1, 2, 3, and 4. You see, this main interval, the period, from 0 to 2 pi is divided into 4 equal segments, 4 equal subintervals. 1, 2, 3, 4. So that means we're going to do the same here. All right, but first thing, the original graph starts at 0. In ours, doesn't move either to the left or to the right, so that means it starts also at 0. Okay, so it's also going to start at 0. Okay, starts right there. Then this one repeats after every 2 pi. So from here to here is 2 pi. The period of this one is not 2 pi. The period of this one is 4. So this one is going to go from 0 to 4 instead of from 0 to 2 pi. So let's say this is 1, 2, 3, 4. Okay, it's going to end there. All right, and so I divided that into 4 equal pieces already there. 1, 2, 3, 4. And now look at what we're going to do. We're going to follow all these points, chase them around after applying the transformation. So these points have not moved. This point, the start has not moved to left or right, and I know it ends at 4. Okay, so all I want to do is really figure out what are the y coordinates of the corresponding points over these tick marks. What are the y coordinates? If you remember from college algebra, the y coordinate is only affected by the numbers outside of the function. So that means only this 2 and that 1 affect the y coordinate. And that says multiply by 2, add 1. So in order to find the new y coordinates, I'm going to take all of these y coordinates over each of these main tick marks, 1, 2, 3, 4, 5, and multiply them by 2 and add 1. Okay, that's what is going on here. Multiply the y coordinate by 2 and add 1. All right, so let's start. The y coordinate here is 0. Multiply by 2 is 0, plus 1 is 1. So actually, that means that my graph should really start here. That point has moved up, so that's not really the beginning. It is right here. All right, and you can tell because the whole graph is supposed to be shifted upward. So actually, this is where I am at. Okay, that is where I am at. All right, now let's follow the other points. Over the second tick mark, the corresponding to that one, the y coordinate is 1. And now we're going to do times 2 plus 1. So the y coordinate is 1 times 2 is 2 plus 1 is 3. So we're supposed to be at 3 over the second tick mark. 3. Now let's follow the third point. Third tick mark, the y coordinate of that point is 0. So 0 times 2 plus 1, you get 1. So we're here again. The y coordinate of the point corresponding to the fourth tick mark is -1. -1 times 2 is -2 plus 1 is -1. Okay, so it's -1. That's what we got. Okay, so I got that y coordinate, -1 times 2, -2 plus 1 is -1. Okay, and lastly, the y coordinate here is 0. So the point corresponding to the last tick mark, which is this one, the y coordinate is 0 times 2 is 0 plus 1 is 1. And there you have it. Now connect these points following the shape that you're supposed to follow. This shape in this case is curvy shape. There you go. That's the graph of, this doesn't have to be perfect. This is a graph of one period of my graph. And I know that this repeats on forever. So if I keep going, the graph is going to look like that. Okay, and in the homework and on the exam, these are going to be multiple choice. So you basically have to match among all the choices, the graph that follows that same shape and has starts at the correct points. So at 0 it is 1, at 2 it is 1, at 3 it is -1, over 1 it is 3, etc. Okay, and finally, one more thing that I want to point out is that you see the midline, y equals 1. That is the line that really is supposed to pass right through the middle. And if you were to draw it, which is not required, but if you were to draw it, the horizontal line y equals 1, it is this one, okay? The line at height 1. And you see that indeed it does pass right through the middle. And that's it. Okay, now let's do another example. This one says 3 sine of pi over 4x minus pi over 4. All right, so let's start the same way as the other one. Let's start by finding all the main things. So first, the amplitude. The amplitude is the absolute value of A equals, in this case, the A is 3, so we're talking about the absolute value of 3, which is just 3. Then we need the period. The period is 2 pi over B. Okay, and then we plug in what B is. B is pi over 4 in this problem. It is the coefficient of the x, the number that is right in front of the x. So B is pi over 4. And then simplifying, what is that? You get 2 pi times 4 over pi. And canceling the pi's, you get 8. So the period is 8. This graph is going to repeat itself every 8 units. Okay, what else did we find in the other one? The midline. In this case, the midline is 0. This is a midline, right? The midline is y equals d. There is no d in this equation. So what that means is that the x-axis, the line y equals 0, is actually the line that passes right through the middle. So the vertical shift, which is another interpretation of the d, it is 0. So in other words, no vertical shift. So the original graph is not moved up or down. And lastly, the phase shift, the formula is C over B. And remember, the C is that number right there, but that is the opposite sign. So if I see a minus, I'm going to put positive. If that were positive, I would put minus here. So I see it minus, so I'm going to put positive pi over 4. And then B, which is pi over 4. And this is 1. So that means the graph is shifted 1 unit to the right. Because we got positive. If we get negative, that means to the left. Okay, now we're ready. So that's it. We're pretty much ready. Let's draw our axis. All right, those are my axes. And the phase shift is 1. Okay, so this is again a sine function. Our function is still a sine. So this is another one of a sine, example of a sine. All right, so here we are. This is what we have to have in mind. The original one starts at 0. Okay, 0. So, but this one though has been shifted to the right by 1. So that means we're going to move that dot from 0, 1 to the right. Tick mark. Okay, that I know now that that's where we're going to start. This is 1. All right. Now, we're going to figure out where it ends, because we need to know where our main period starts and ends. The original one goes from 0 to 2 pi. This one goes from what to what? Well, it starts at 1, but I know the length of that interval is 8. Okay, in the original one is 2 pi, but in this one we're trying to draw, the length of that interval is 8. That is the length of that interval. And you start at 8, and the length is 8, so that means where you end up at. If you start at 1 and you end 8 units later, you end up at 9, right? 1 plus 8 equals 9. So that's where you end. You end at 9. All right. So I know now where I begin, where I end. Next up, I need to divide my interval into 4 equal pieces. 1, 2, 3, 4. I need to divide this into 4 equal pieces. So how would you divide that into 4 equal pieces? Think about it for a second. You would have to go by how many units in order to divide it into 4 equal pieces? It should be by 2. So, right, so I have 8 units divided by 4 equal pieces. That means 2. You go by 2. So that means the next one is going to be 3, 5, and 7. All right, so I try to divide that into 4 equal pieces. My graph is not the best. All right, now let's chase around the coordinates for the points corresponding to each of these tick marks. And remember, only the numbers outside the function affect the y coordinate. In this case, the d is 0. So you multiply by 3 and add 0. Multiply by a and add d. Multiply by 3 and add 0. Okay, so let's do that. So the point that goes over the first tick mark is this one. The y coordinate is 0 times 3 is 3. It's 0. 0 times 3 is 0. Plus 0 is still 0. So that means 0. So that's where we are. The point that goes over the second tick mark, that one, has y coordinate 1. And now you multiply by 3 and add 0. So 1 times 3 is 3 plus 0 is 3. So that means the y coordinate or the point that goes over this tick mark is 3. All right, next up, 0, y coordinate 0. Times 3 is still 0, plus 0 is still 0. So 0. Y coordinate here, negative 1 times 3 is negative 3, plus 0 is still negative 3. So 1, 2, 3, negative 3. And lastly, the last coordinate, this one, the y coordinate of that is 0, times 3 is 0, plus 0 is still 0. So 0. All right, and that's it. Now let's connect them in the wavy shape that we know we're supposed to have. And that is the graph of a main period. And you know this goes on forever and it repeats. Okay, and that is it. Now, when you're doing it on the homework, just make sure that you choose the graph that matches this perfectly. So at 1, it should be 0. Over 3, it should be 3. At 5, it should be 0. At the 7 tick mark, it should be negative 3. And at 9, it should be 0. And that's it. Okay, now we're going to do our last example, and this one is an example of a cosine transformation. And the first two that we did were sine transformations. Now this is a cosine one, but it's done exactly the same way. All right, so let's start by finding the amplitude. amplitude is absolute value of A, which is absolute value of -2, which is 2. Then we have the period. The period is 2 pi over B. And the B is pi over 2. So this is really then 2 pi times 2 over pi. That cancels and you get 4. Okay, so this is going to repeat every 4 units. Then the midline is y equals 3. Vertical shift is the d as well. So this is 3. And it's positive, so that means 3 units upwards. So the original graph is going to be moved up 3 units. And lastly, phase shift. What is the phase shift? Phase shift is C over B. In the C, remember, it is the opposite to what you see here. I see a plus pi, positive pi, so that means I'm going to put negative pi. And then the B is pi over 2, so this is negative pi times 2 over pi, divided by something is the same as multiplying by the reciprocal. Cancel the pi's and you get -2. So that means the original graph is moved to the left 2 units. So shifted, this means shifted to the left 2 units. Okay, and now we're ready. Now we are absolutely ready. By the way, you probably have noticed that we don't really use, when we're making the graph, we haven't really used the amplitude or the midline, but you can use those to basically double check your work, right? So if you are like in doubt, you can double check your work. For example, in this one, we never really use the amplitude, but after we're done, we can use that to double check our work, because if we did this correctly, the amplitude should be 2, and the amplitude is the distance from the midline to the highest point. And you see that that is exactly 2, because you go from 1 to 3. Okay? All right. Anyway, so now let's draw our graph. Okay, the original graph is shifted to the left, so I'm going to leave a little bit more room on the left side now. Okay, and there you go. So those are my axes. Okay, let's see what we get. Now we are following the basic cosine graph. Okay, so you have that in your head, or you write it in draw it in a corner and use it as a reference. Okay, so this is our reference. This is going to be a reference. Okay, but we're not ready quite yet. Okay, this one is shifted to the left 2 units. All right, so that means instead of starting above 0, we're going to start 2 units to the left. 1, 2. And this is -1, this is -2. Okay. Now, the period is going to tell us where we're going to end indirectly. So we're going to end 4 units later. That doesn't, right? This 4 doesn't mean we end at 4. It means we end 4 units later from our beginning. So if we start at -2, this is our first tick mark, we have to end 4 units later. So that means -2 plus 4, so that would be +2. So you have 1 and 2. Okay, so that is going to be our main interval right there, our main period. We start at -2, end at 2. Further than that, on either direction is just repetition. All right, and now we're ready. We see that we started at -2, we ended at 2. The next thing we really needed to do was to divide the interval into 4 equal pieces, just like for this one. We have to divide it into 4 equal pieces, but that kind of happened organically there. We didn't really have to do it, but if it hadn't happened, that would be the next thing you need to do. Divide the beginning and end into 4 equal pieces, okay? 4 equal subintervals. Now we're ready. Let's do it. All right, the coordinate of the beginning, the coordinate of the point that goes above our first tick mark right here is, in the original graph, 1. In the original graph is 1. But in this one, I'm going to multiply by a and add d. So 1 times -2 is -2 plus 3 is 1. So that's where we end at, 1. 1. Next, the y-coordinate of the point over the second tick mark in the original basic graph is 0. In our new one is going to be 0 times -2 plus 3. 0 times -2 is 0, plus 3 is 3. So the y-coordinate above this tick mark is 3. Okay, 3. Now let's follow the next one. The y-coordinate is -1. -1 times -2. -1 times -2 is +2. Plus 3 is 5. So the next one is actually 5. So this is not long enough. So I'm going to just make it a little bit bigger. 5, right there, 5. Now, the y-coordinate of the point over the fourth tick mark is 0. So 0 times a plus d. 0 times -2 is 0, plus 3 is 3. So we're supposed to be right here. And then lastly, the y-coordinate of the tick mark, of the point above the last tick mark, the basic original graph is 1. So 1 times -2 plus 3. 1 times -2 is -2 plus 3 is 1. So we have 1. Okay, so those are our 3 points. And note that, our basic graph is like goes down, right? Our original cosine goes down. This one goes up. And that's because, if you remember from college algebra, when you multiply by a negative number outside, that flips the graph upside down. It takes the y-coordinates, makes them, changes the sign basically. So this graph is then turned upside down and then shifted up by 3. It's what we call a reflection across the x-axis. It's a reflection. So that's why it's upside down. So instead of going down, this one is going to go up. And now when you connect to the points, though, if you're making a nice picture, don't be sloppy and make it look like that. It's not a triangle, all right? It's not a V. We should be a little bit more careful and make sure our graph follows that shape, that nice shape. So our graph is going to look more like that. There you go. That's better. It's like this bell shape. Okay, and that's it. So that's the main part. After that, we know that it repeats forever, goes back up, and just the same wavy shape. And that's it. That's how you draw sinusoidal functions.